So this says to find the linearization of the function at x equals a and use it to approximate f of a plus 0.2. All this means is find the tangent line for x equals a and then use the tangent line to find out f of, or whatever the tangent line is, of a plus 0.2. Does that make sense? The idea is we have some function. You just leave them there. You don't have to write this part down. But if I have some function and I get a tangent line at x equals a, and I plug in, say, like right there, that's a plus 0.2. If I have some kind of function and I get an equation for a tangent line, I can plug in a plus 0.2 and I would get that y value instead of the actual y value, which is almost the same thing. Do you guys understand how this is an approximation? So all this means, find the linearization, that means find the equation of the tangent line for the function at x equals a, which is 0. So find the equation of the tangent line when x equals 0, and use that tangent line to approximate 0 plus 0.2, so 0.2. Do we understand that? So can I do this really quickly? That, like, literally, all it means, you have 3 problems like this. It literally means find the tangent line when x equals a, and then find this. You're plugging in whatever a is plus 0.2 or 0.1 or whatever your problem says. So finding the tangent line, that's the linearization. The tangent line, I'm going to use y minus y1 equals m times x minus x1. x1 is what? 0, because we're finding the tangent line at x equals a, which is 0. How do I find y1? Yeah, you plug in your x1 to your function. So y1 is the square root of 1 minus 0. So that's just 1, because I plugged it in there. And then m, how do I find m? Take the derivative. So that would be f prime of 0, right? So I need to find the derivative. F prime of x equals 1 over 2 root 1 plus x times 1, yeah? So if I plug in 0, I just get 1/2. So far, so good. So my tangent line equation, I'm going to write in red, that will be y minus 1 equals 1/2 x. Yes? The way some people write it, they change the y to a lx because it's a linearization of the function f of x. So I would add the 1 over. This is just so that it looks the same in your books or in a book. So the linearization of f of x is this. Do we understand? It's just the tangent to f of x at whatever point they said. It's when a, like, if a is some number, we'd say the linearization is centered at a, or in this case, centered at 0. If we had a different a value, then we would have a different linearization because that would correspond to a different tangent line. Look, the tangent line's red, and then the answer is red because they're the same thing. So, there's one more part. Find out, or approximate f of a plus 0.2. We're going to approximate this just by plugging in a plus 0.2, which is just 0.2. So, L of 0.2, I'm going to 0 plus 0.2, so that it looks the same as what it says here. That is going to be whatever this is, 0.2 divided by 2 plus 1. And I'm going to do that in my calculator. Maybe I do, I don't know. Is that right? 1.1? Looks like it would be. Okay, at math. So there we go. What's the actual value? What's the actual value of f of actual? This is, in your problems it says to like see how close it is. They just take the actual value minus the approximation and then compare it. But like I don't care about that. So I would just find out the actual value, see how close it is, or just compare it. You don't have to really do anything, but find the actual value. So if I plug in the square root, because the actual value is with real f, if I plug in the square root of 1.2, what do I get? Square root of 1.2. And it is close, 1.095, because it's an approximation. It's slightly off. The question was why, like how come a is 0? That's just some spot on the graph where you're approximating like close to. So if we chose, like we wanted to approximate something over here, say like -1, a would be -1. And then we find the tangent line at -1. If we wanted to figure out like what -1.2 was, then the linearization centered at -1 would be a good approximation for when we plugged in the -1.2. How did I get the actual number? This part? I plugged it into the actual function. So the linearization approximates this for values that are close to a equals 0. To get the actual, I just plugged in the 0.2 to the actual function.